Welcome to my channel, The Proper Guidance. Here we are today to discuss about chapter number 3 of class 12 computer science, and that is about stack. This is a very important chapter, and in this chapter we will discuss about stack, operations on stack, implementation of stack in Python, notations for arithmetic expressions, conversion from infix to postfix notation, evaluation of postfix expression. Okay, so these are the topics which are discussed in this chapter. So let's start. First part, the introduction. In introduction, we will recall about the previous data types which we have already completed in our previous classes. That is about string, list, set and tuple, etc. And these are the data types that can be used to represent collection of elements either of the same type or different types, right? And now see, multiple data elements are grouped in a particular way for faster accessibility and efficient storage of data. That is why we have used different data types in Python for storing data values. Such grouping is referred as a data structure. So, what is a data structure? A data structure defines a mechanism to store, organize and access data along with the operations that can be efficiently performed on the data. So, this is our very basic definition of data structure, and if you notice that, for example, string is a data structure containing a sequence of elements where each element is a character. On the other hand, list is a sequence data structure in which each element may be of different types. We can apply different operations like reversal, slicing, counting of elements, etc. on list and string. Hence, a data structure organizes multiple elements in a way so that certain operations on each element as well as the collective data unit could be performed easily. Okay, and stack and queue are two other popular data structures used in programming. Although not directly available in Python, it is important to learn these concepts as they are extensively used in a number of programming languages. In this chapter, we will study about stack, its implementation using Python as well as its applications. Okay, so here is the stack, and this is our main topic. What is a stack? First, you should know the concept of stack. What is actually stack means? What is the very layman concept of stack? Look, we have seen piles of books in the library or in your book study table. There are so many books. You have kept them on your table, one above the other. There are lots of books in a pile, and piles of books in the library or stack of plates at home. To put another book or another plate in such a pile, we always place the object at the top only, right? Likewise, to remove a book or a plate from such a pile, we always remove the object from the top only. This is the concept of stack. This is the concept of stack, that when you have to keep a new element, you have to put it on the top. Okay, and when you have to remove some element, then you have to remove from the top only. Okay, so this is the actual concept of stack, that is, add to the pile and delete from the pile, and this is only from the top only. This is because in a large pile it is inconvenient to add or remove an object from in between or bottom, right? Such an arrangement of elements in a linear order is called a stack. So, what is the basic concept of stack? Suppose you have 3 books on your table, one book, and on this book you have keep another one, and you put another book on the second book. Now, there are only 3 books. You may manage to handle the last one. The first book you can keep out from that, from those 3 books, right? But if there are so many books and in a stack in the library, this is very inconvenient to put out the first book from the very bottom place, right? And so if we want the first book, we have to first take away the third book, after that the second one, and then the bottom one. That is the first one. And this is the concept of stack. And this concept is implemented in the data structure. And how it is implemented? It is implemented in such a way that such an arrangement of elements in a linear order, the highlighted one, please notice the line. Such an arrangement of elements in a linear order is called a stack. We add new elements. We add new elements or remove existing elements from the same end. Okay, commonly referred to as the top of the principle. So this is the very basic concept of stack. It thus follows the last in, first out. Last in, first out, the name implies this principle is implying that last in, the last element which you have entered, and when you just keep out that particular element, last in, first out. The very last element will be taken first, right? And the very first element will be taken at the last one. That is the element which was inserted last. The most recent element will be the first one to be taken out from the stack. And here is the diagram of stack of plates and books. Look here, the blue book, the very blue book in the bottom place. If you want to take this book, all the books will be fall down, and that's why we have to first take out this red book, after the orange one, then the yellow one, and so and so and so. And lastly, after taking out the green book, then we can collect the bottom one, that is the blue book, right? So this is the very basic concept, last in, first out. So when we have to take out the book, we are going to take out the book, the red book first, and see, this is the book you have kept at the last one. Okay, in order, this is the last book you have kept, and when you are going to take out the books, you have to first take out this one. So this is the concept of stack here. Now, applications of stack. Some of the applications of stack in real life are pile of clothes in an almirah, multiple chairs in a vertical pile, bangles worn on wrist, pile of boxes of eatables in pantry or on kitchen shelf. Some examples of application of stack in programming are as follows. The very basic real life examples are very used to, you can understand it very clearly, but in application of stack in programming are as follows. When we need to reverse a string, please notice the example very minutely, that when we need to reverse a string, we are reversing a string. Suppose string means your name, anything. Suppose the string, the word itself is a string, and when we are going to reverse the string, the word string, we first will take out G, then you have to display N, then I, then R, then T, and then S. Now, suppose in this way, the books are just arranging in this pile, we are taking that particular word, string, in this way. All the characters will be kept one after another. One after another. Oh, sorry. Just wait. One after another. When you need to reverse a string, the string is traversed from the last character till the first character. That is, characters are traversed in the reverse order of their appearance in the string. This is very easily done by putting the characters of the string in a stack. We use text or image editor for editing the text or image, where we have options to redo or undo the editing done. When we click on the redo or undo icon, the most recent editing is redone and undone. In this scenario, the system uses a stack to keep track of changes made. While browsing the web, we move from one web page to another by accessing links between them. In order to go back to the last visited web page, we may use the back button on the browser. Let us say we accessed a web page P1 from where we move to web page P2, followed by browsing of web page P3. Currently we are on the page web page P3 and want to revisit web page P1. We may go to a previous visited web page by using the back button to the browser. On clicking the back button once, we are taken from web page P3 to web page P2. Another click on back shows web page P1. In this case, the history of browsed pages is maintained as stack. Clear? And while writing any arithmetic expression in a program, we may use parentheses to order the evaluation of operators. While executing the program, the compiler checks for the matched parentheses. That is, each opening parenthesis should have a corresponding closing parenthesis and the pairs of parentheses are properly nested. In case of parentheses are mismatched, the compiler needs to throw an error. To handling matching of parentheses, stack is used. Clear? So, this is the very basic concept of stack and its operations and its implementation in real life as well as in data structure. Now, operations on stack. What are the operations we can do on a stack? As explained in the previous section, a stack is a mechanism that implements last in, first out arrangement. Hence, elements are added and deleted from the stack at one end only, and that is the top. The end from which elements are added or deleted is called top of the stack, the highlighted one. You can see here that top of the stack. Two fundamental operations performed on the stack. Those are, one is push, another one is pop. In this section, we will learn about them and implement them using Python. Now, we will learn about push and pop operations. Push adds a new element at the top of the stack. It is an insertion operation. We can add elements to a stack until it is full. A stack is full when no more elements can be added to it. Trying to add an element to a full stack results in an exception called overflow, when there is no space and we are going to adding new elements one after another. This is the case when overflow. This is the case when it will result an exception. This is known as overflow. So, what is the concept of overflow? The name indicates that when there is no place to add any new element, no space in the stack, and we are going to input something new, and that is the concept that the exception arises, that is overflow. And pop operation is just vice versa of push. That is, push is for add a new element and pop operation is used to remove some element from the stack. We add some new element in a stack with the help of push operation, and the other one, the pop operation, helps us to remove some item from the stack. Already there is some element in the stack and we are going to remove those elements from the stack. We use pop operation. Okay, and pop operation is used to remove the topmost element of the stack, that is the element at the top of the stack. It is a delete operation. So these two operations are totally different to each other. One is used for inserting a new element in the stack and the other one is used to delete some element from the existing stack. So we can delete elements from a stack until it is empty. Now see, when there are so many elements in the stack, we are using pop operations one by one, one after another, and all the elements which are already existing in the stack will be deleted one after another. Until it is empty, we can use that particular operation, pop operation. That is, there is no element in it. Trying to delete an element from an empty stack, what will happen? There is another exception occurs, and this concept is known as underflow. This is actually the reverse concept of overflow. This is underflow. This means that there is no element in a stack and we are applying the pop operations to delete some elements. Okay, this is very ghostly in nature. Now there is no elements in the stack, but still we are doing pop operations on the stack to empty something. So this occurred an exception. It results in an exception called underflow. So these are the two basic operations used in stack. One is push and another one is pop. One operation is used to add something and one is to delete something. Completely different, opposite to each other. And when we are going to add some new elements in a stack, when already the stack is completed, there is no any other space to insert some element, we are going to use push operation. Then it will arise an exception that is known as overflow, as well as when there is no elements in a stack and still we are going to use pop operation, it will result in an exception which is known as underflow. Okay, I think you people can understand it very clearly. And a stack is used to insert and delete elements in last in first out order. This is the very basic concept, and same principle is followed in adding and removing classes from a pile of classes. This is very real life example. Okay, and we are here not to understand the real life. Actually we are going to do some data structure oriented programming will be there, and we have to do this. Okay, so empty stack, there is a picture. Look at the picture, the diagram. Here is first one, number 1, there is the empty stack, and after that when we use the operation push 1, that is at the top of the stack we are adding some elements. Suppose here is the picture of a glass. Actually what happened, you can't see the data in your machine. We have to imagine what it will happen when we are just keeping a glass one above the other. We are inserting making a pile of glasses, and there we are using the push operation. Push 1, glass number 1, push 2, glass number 2. The glass number 2 is inserted on the glass number 1. Okay, and thereafter we are using pop. We are using pop here. When we use pop, 2 will be removed, the glass on the top will be removed, and again we use push 3. When we use push 3, glass number 3 will be inserted on glass number 1, and again if you push something, push 4, it will give you glass number 4, 1, 3, 4, and when we use pop, the glass on the top will be removed from that particular pile of the glasses. And again if you use pop function, then what will happen? It will happen that the glass number 3 will be removed from there, and pop 1, again pop, the stack will be empty and we will get the empty stack. So this is the process. This is the procedure we can use push and pop operations on a stack. Okay, now implementation of stack in Python. How to implement stack in Python? We have learned so far that a stack is a linear and ordered collection of elements, right? The simple way to implement a stack in Python is using the data type list. Okay, we can fix either of the sides of the list as stop to insert or remove elements. It is to be noted that we are using built-in methods append and pop of the list for implementation of the stack. As these built-in methods insert or delete elements at the rightmost end of the list, hence explicit declaration of top is not needed. Okay, so let us write a program to create a stack. where a stack of classes are given in figure 3.2, in which we will insert the delete class and delete elements. Here the elements, you can see here the element will be considered as classes. Actually this will be the elements which you are going to insert something. Okay, so check if the stack is empty. Find the number of elements, read the value of the topmost element in the stack, and so on. The program shall define the following functions to perform these operations. Okay, some functions will be used here. We will do so by assigning an empty list to the identifier named class stack. This is the identifier, and here we will assign a list. Class stack is equal to list. Okay, a function named isEmpty to check whether the class stack is empty or not. Okay, remember, trying to remove an element from an empty stack would result in underflow, so we have to check it whether it is empty or not. So def isEmpty class stack if len class stack is equals to 0. If it returns 0, means return true, else return false. A function named push to push a new element in stack. This function has two parameters: the name of the stack in which the element is to be inserted, class stack. This function has two parameters: the name of the stack in which the element is to be inserted and the element that needs to be inserted. We know that insertion of an element is always done at the top of the stack. Hence we shall use the built-in method append of list to add an element to the stack that always adds at the end of the list. As there is no limit on the size of list in Python, the implemented stack will never be full unless there is no more space available in memory. Hence, we will never face overflow, no space for new condition of our stack. Definition of push class stack element, class stack.append element, a function named size to read the number of elements in the class stack. We will use the len function of the list in Python to find the number of elements in the class stack. Okay, and a function named top to read the most recent element in the class stack also. So a function named pop to delete the topmost element from the stack. It takes one parameter, the name of the stack from which element is to be deleted, and returns the value of the deleted element. The function first checks whether the stack is empty or not. If it is not empty, it removes the topmost element from it. We shall use the built-in method pop of Python list that removes the element from the end of the list. And here is the coding. You people please go through this coding. This is very easy one. A function named display to show the contents of the stack. Define display class stack x equals to len this one, print this one. For in range we are using a for loop here, and then print class stack I. This means all the elements will be printed here. Once we define the above functions, we can use the following Python code to implement a stack of classes. That is, class stack equals to list, that is create empty stack, add elements to stack, element equals to class 1, print pushing element of push class stack element class 2, class 3, and all those things will be printed like this. Display number of elements in the stack, print current number of elements in the stack, size this. You people please go through this coding section. This is very easy one. If there is any problem, please comment me. I will again come to you to clarify the coding, but this is very big coding, something lengthy but very easy one. And notation for arithmetic expressions. After that, here we are to discuss about notations for arithmetic expressions. Look, in our arithmetic section, when we are doing some operations, suppose addition, subtraction, multiplication, division, whatever, what we do, we use the operators in the mid of two operands. Okay, we write arithmetic expression using operators in between operands, like x plus 2 or x plus y, like this thing now, 2 plus 3, like this one, the 2 plus 3 equals to 5. But the operands will be 2 and 3, and plus is the operator. And when we see that there is a plus operator, then we know that it will sum up the value of two variables, suppose x and y. When x equals to 2, y equals to 3, it will give you the result as 5, like this thing. The main topic is here that using parentheses to order the evaluation of operators in complex expressions, and in our primary section we have done the Bodman's rule to evaluate it. Okay, B for bracket, O for off, D for division, A for multiplication, A for addition, and S for subtraction rule. And this is the very basic concept how to calculate any given expression, right? So, Polish mathematician Jan Lukasiewicz in the 1920s introduced a different way of representing arithmetic expression called Polish notation. This is a very important one. In such notation, operators are written before their operands. Okay. In Polish notation, operators are written before their operands. Suppose you are going to add 2 and 3 and we have to write down plus 2, 3. It will give you the result. That is, it will sum up 2 and 3 and give you the result 5. Okay. So, in such notation, operators are written before their operands. So, in such notations, operators are written before their operands. So, the order of operations and operands determines the result, making parentheses unnecessary. For example, we can write x plus y in Polish notation as this one. X plus y, this is written as plus xy. This is also called prefix notation because the operators is used before the operand. It is known as prefix notation, as we prefix the operator before operands. By reversing this logic, we can write an expression by putting operators after their operands. And for example, when we write x plus y as this xy plus, this is called reverse Polish notation. Okay. So, this is also known as postfix, prefix and postfix notation, and this is new to you. To summarize, any arithmetic expression can be represented in any of the three notations. Okay, infix, prefix and postfix, and here is a list, infix, prefix and postfix notation. Here is a list, you people please go through the list. Infix is very familiar to us. Whatever you have done in mathematics, all are of infix type, right? All the operators used in between two operands, and this is infix. We are very much more familiar with this particular section, infix, but we are not so much familiar with the prefix or postfix operations, expressions, right? And prefix means Polish notation and postfix means reverse Polish notation. And how to write down all these things? Here is an example. Please go through. First one, in infix, here is a line, x asterisk y. This means x into y plus z. Okay, plus z. And this section in prefix is written like this, plus z multiplication xy. First x and y, and you have to first multiply x and y. So, here is the notation. This notation comes first of x, y, and after that the resultant will be added with that particular z. This is the referent value and you have to add this. And when you are adding this thing, so this summation symbol will comes first. Is this one, summation z, and the same rule follows here for this particular part. And this is your home talks. You people do one thing. First, you evaluate this section. Take some value for x, y and z, the fixed value. These are the variables. You can take x equals to something, suppose x equals to 2, y equals to 3, z equals to 5, and then evaluate this section in infix expression. And same thing, it will be applied here in this section prefix, and after that in this example postfix, you have to apply it and find the value. The value will be, resultant value will be same, but the presentation is different, the notation is different, and this different thing you have to learn. And this is prefix, and the reverse Polish notation is written like this, xy multiply z, like this. Okay, so please go through. and conversion from infix to postfix notation. This is very vital. We have to convert. In your exam, there may be some examples given, and you are asked to convert it from infix to postfix or postfix to prefix like this. Okay, it is easy for humans to evaluate an infix expression. Consider an infix expression like this: x plus y by z. While going from left to right, we first encounter plus operator, but we do not add x plus y and rather evaluate y by z, because we know the Bodmas rule that first you have to evaluate the division section and after that plus, right? So followed by addition operation. This is because we know this. Okay, but how do we pass this precedence knowledge to the computer through an expression? This is the actual question. How do we pass this precedence, this priority, which operation will be done first and which will be after that, this priority and this precedence knowledge to the computer through an expression. In contrast, prefix or postfix expressions do not have to deal with such precedence because the operators are already positioned according to their order of evaluation. Hence, a single traversal from left to right is sufficient to evaluate the expression. Okay, in this section we will learn about the conversion of an arithmetic expression written in infix notation to its equivalent expression in postfix notation using a stack. During such conversion, a stack is used to keep track of the operators encountered in the infix expression. A variable of string type is used to store the equivalent postfix expression. Okay. Now, here is an algorithm. Algorithm to convert an expression in infix notation to postfix notation. So, what is the algorithm? Algorithm means the steps. What are the steps to be taken to convert some given expression from infix to postfix notation? Clear? First step, create an empty string named postx expression. For expression, we are abbreviated the name that exp, postexp, to store the converted postfix expression. Next, input infix expression in a variable, say in exp. Next one, for each character in exp, repeat step 4. What is step 4 here? If character is a left parenthesis, then push on the stack. Else, if character is a right parenthesis, then pop the elements from the stack and append to string post exp until the corresponding left parenthesis is popped, while discarding both left and right parentheses. Okay. Else, if character is an operator, then if its precedence is lower than that of the operator at the stack of the stack, then pop elements from the stack till an operator with precedence less than current operator is encountered and append to string post exp before pushing this operator on the post stack. Else, push operator on the stack. Else, append the character to post exp. And step number 5, pop elements from stack and append to post exp until stack is empty, then output post exp. Now, here is an example. Let us now use this algorithm to convert a given infix expression. Okay, listen one thing. This algorithm, when you are going through this study material, you people do one thing. You may write down this algorithm in your copy. After that, you just go through this picture. Okay. And now see, let us now use this algorithm to convert a given infix expression x plus y. Look here, x plus y is in a parenthesis divided by, again there is a parenthesis, z multiplied by 8 into equivalent postfix. This is infix because you can see here that the operator is in between two operands, right? So this is an infix expression. We have to convert it to equivalent postfix expression using a stack. Now see, the stack is used to track the operations and parentheses, and a string variable contains the equivalent postfix expression. Initially, both are empty. Each character in the given infix expression is processed from left to right, and the appropriate action is taken as detailed in the algorithm. When each character in the given infix expression has been processed, the string will contain the equivalent postfix expression, right? Now see here, symbols are here. Symbols are here. First one is the parenthesis. When we see the parenthesis, what to do? This is push operation. Here I am showing you. here it is. If characters, step number 4, go to step number 4. If character is a left parenthesis, then push on the stack. So our first symbol is here a left parenthesis, so push it. Initial stack is empty, then push it, and after that append to string post exp, x is here. After that push again the operator plus is here. When operator plus is here, we are adding to this one, append this thing, and x, here is y, append to the string post exp. This is the postfix string. Post exp is used for the postfix string which you have to show at the last time. So here we are writing here like this, x push and y when xy plus this one. Now see, symbol, this is the right parenthesis, and when we see the right parenthesis on the above in the above section, the algorithm, if you notice the algorithm properly, you can see when there is a right parenthesis, we have to pop the elements up. So pop elements from stack till left parenthesis is encountered. So we have to pop it out. Pop what? Popped this 2 1 plus and this parenthesis, and what we will get? We will get the empty string again, and after that push what? This thing, this is the operator, this is an operator, and again this left parenthesis is here, so we have again push it in the stack, xy plus, and this thing append to string post exp, z is here, so append to string to post exp, and this is in the post exp section. You can see now, here is the expression, and after that again there is an what? There is an operator, that is asterisk symbol, and then again you have to push it in the stack, and after that here is 8 means a string, you have to add it in the post exp, so x y plus z 8. Now when we get right parenthesis, we have to pop out all the elements from the stack till left parenthesis is encountered and append the popped element in post exp. So we have again popped out all these things, and popped what? Popped this one, and after that final stack we will get what? We will get this thing. Okay, so conversion of infix expression, this thing, this is to postfix expression. To postfix notation, we get this one. This is the actual postfix notation, we get it xy, x plus y in parenthesis divided by what? Divided by z into 8 in parenthesis. This expression we have in postfix section what? This one, xy plus z8 asterisk and this one. In postfix notation, there is no need for any parenthesis because all the operators are used after the operand. So you people please go through this chart. First you go through this algorithm, write it down in your copy, and opening that particular copy, each by each step you will match with this symbol and this chart. After that it will be very clearly understood by you that how the expression is changed, expression notation is changed from infix to postfix. Okay, now evaluation of postfix expression. This is the example of conversion from infix expression to postfix expression. Now we will learn evaluation of postfix expression, how to evaluate postfix expression. Okay, so here is also another algorithm to evaluate a postfix expression. First, input postfix expression in a variable, say post exp. Next, for each character in post exp, repeat step 3. And what is step 3? If character is an operand, then push character on the stack. Else pop two elements from the stack, apply the operator on the popped elements and push the computed value onto the stack. If stack has step 4, if stack has a single element, then pop the element and output as the net result, else output invalid postfix expression. Now again, you people do one thing. You people just write down this algorithm in your copy and matched with the given example. Example 3.2. Okay. Now see, here is the postfix expression. This one we have to evaluate this postfix expression. 782 multiplied with 4, these things. Okay. First thing, symbols will be written in this way. Action. When you get some symbol, we have to push the symbols in the stack. So first one is 7, push it, then 8, push it, then 2, push in the stack. Now symbol is an operand. When we get some operator, these are the operand 782, and when we get a symbol of operator, that is asterisk here, pop two elements, apply the operator and push back the result. Okay, so two elements from the top in the stack, that is 2 and 8, and the operator we get, that is the symbol of multiplication. So 2 and 8, when we multiply 2 and 8, we will get what? We will get 16, right? 16, and then push the resultant value in the stack again. So instead of 2 and 8, we are operating 2 and 8 with the help of this operator, that is asterisk symbol, and after that 2 into 8 equals to 16, and we are writing here 16. Okay, and after that again we get some operand, that is 4, push it in the stack, 4 is here, then again we get some symbol, and this symbol is for this is the division operator. Pop two elements, apply the operator and push back the result. So two operands are 4 and 16, and this is the operator. So 16 by 4 equals to 4, and again we write down here 4. After that we get one symbol, that is plus, and again when we get some operator, we have to pop out the elements from the stack, that is 4 and 7, and apply the operator to those operators. So this is the summation operator. So 4 plus 7 equals to 11, and we have to write down that 11 in the stack, means we have to push it in the stack back. So 11, and after that the final stack will be empty, so we have to pop out that particular value, the single value, that is 11, and this is our result. Result will be 11, and this is the way we evaluate some given postfix expression. Okay, this is very, very important. You people do one thing. You people please go through this particular algorithm first. I repeat that please write down the steps in your copy, and then very minutely notice the given example, and along with this picture. This is given in a very clear way, and I can think that you can do it very easily. Okay, so this is our chapter. We have completed chapter number 3. This is stack. If there is any query, any problem, please feel free to ask me, and thank you for watching.